We're going to be looking at completing the square today. So let's look at our first problem that we have listed here. We have that x squared equals 16. If I think about this one, the obvious answer would be that x, oops, let's get a white. Yep. X, oh my goodness. X equals 4. And because x times x or 4 times 4 is 16. But if you think about it, negative 4 would also be an answer because negative 4 times negative 4 is also 16. So what we're going to have to say is, if we're going to solve some that are, say, a little harder than this one, say the one that we have to the right, we're going to say that we can take the square root of both sides. But we have to remember that because it was squared, we will need to remember our plus minus case. So I'll be saying that over and over again. So like I look at this problem here and I know that what's inside of here can either equal a 4 or a negative 4. How I would solve that one is I would say I'm going to take the square root of both sides, remembering my plus minus case. Rewriting, I'll get x plus 3 equals square root of 16, so positive square root of 16, or x plus 3 equals negative square root of 16. Almost got into my little Bitmoji there. So I have x plus 3 is either equal to 4 or x plus 3 equals negative 4 because that's what this inside of here can equal. It can equal a 4 or it can equal a negative 4. Solving this equation, subtract 3 from both sides. X is either equal to 1 or x is equal to a negative 7. And you can check that and see that it would work. If you plugged in a negative 7 plus 3, you get a negative 4. Square a negative 4. Negative 4 times negative 4 is 16. Same with the 1. You'd get a 4. Square it. That would be 16. So let's look at some other problems. All right, let's play. I'm going to look at the one on the left. I'm going to say, oh, I've got the square root of something. Something squared equals a 25. I'm going to take the square root of both sides, remembering my plus minus case. In this case, I'll get 2x plus 3 equals 5, or 2x plus 3 equals negative 5. So just solving this, subtract 3 from both sides, I'll get 2x equals 2, or x is 1. That's one of my answers. Subtract 3 from both sides, I get 2x equals negative 8, and then x equals negative 4. All right, so there's that first one. Let's look at our next one. Got a little bit of a funny thing going on here because when I take the square root of both sides, I'm going to have to take care of that negative. So I'm going to have to say, all right, so here we have them listed. And what I'm going to do is kind of solve this square root first before I do anything to this 3x plus 2. I see that there's a negative, so that's going to be an I. The 12 is 4 times 3. That 4 will come out, make it a 2 onto the square root of 3. Likewise, over here, you'll get the same thing. You'll just have a negative 2i square root 3. I think that might have gone off just a little bit. Let's see if I can fix that for you. There. Okay, I'll move it back in a second. So I'll now subtract 2 from both sides. 3x equals 2i square root of 3 minus 2. Then I'll divide both sides by 3, and I'll get x equals this really ugly. I'm going to write my real part first. All over 3. Lovely. Same thing here, it's just you're going to have a minus guy. So this one will look like x equals minus 2 minus 2i square root of 3. If you walk through the algebra of this, you'll see that one's a plus guy and one's a minus guy. You could write them if you want to, plus minus 2i square root of 3 over 3. That'd be a totally acceptable way to write this one. All right, there are many techniques to solve this one. I could factor this one, get everything to one side. I could factor. I could use a quadratic formula. What I want to do is, because I notice, and if you didn't happen to know this, you would never solve it this way. But if you did, you could notice that this happens to be x plus 3 quantity squared. And it is. If you notice that, then you would say, hey, I could just solve this one by taking the square root of both sides, remembering my plus minus case, and then just have x plus 3 equals plus minus square root of 12. 12 is a 4 times a 3, where the 4 comes out as a 2, giving me x plus 3 equals plus minus 2 onto the square root of 3, subtracting 3 from both sides, and I don't have like terms, so this is as low as it goes, and that's simplified. So that's another way to solve these, and we're going to come up with another way, because this is right at completing the square, which is what we're supposed to be learning for the day. All right. We're going to need to multiply all of these out so that we can learn what completing the square is. So I'm going to list these out for you. If I were to multiply x plus 1 times x plus 1 and FOIL that out and combine like terms, I would get x squared plus 2x plus 1. If I did the same thing for the next one, I would get x squared plus 4x plus 4. X squared plus 6x plus 9. Hopefully you're seeing a pattern here, and you can already tell me what I'm going to be writing down next, such as this middle term would be a 10. This last term would be 5 squared. This middle term is going to be 6 doubled, which is 12x, plus 36. Similarly, I'll get 14x plus 49. So this technique that we're going to learn is very useful whenever we start working with circles and ellipses and hyperbolas and even quadratics. You can't do some of the circle and ellipse problems and hyperbola problems without knowing how to complete the square. And yes, we already know several methods for finding the answers to these quadratics, so it does seem a little pointless when you're working them. It seems a little pointless to be like, oh, what do we need another method for? Well, I'm telling you, you need another method so that you can deal with our circles, ellipses, and hyperbolas later on. All right, so let's look at this one. Normally, if I was going to solve this one and I just wanted to know the answers, what I would normally do is subtract 15 from both sides. And I would do like this, and I'd say, how about x plus 5, x minus 3, I think that works. Yes, x squared minus 3 plus 5 plus 2, okay. And then I would say x equals negative 5, and x equals 3. And that's how normally I would solve it. So let's put that aside. I'm going to solve this one with this new method. So what I do if I'm going to do something called completing the square is I want to make this left-hand side look like something squared equals, and I've got to figure out what square does this look most like. So I look over here and I go, ah, it's this little guy right there. So what do I need? Because I'd like to have inside this x plus 1 quantity squared. So I can take the square root of both sides, remember my plus minus case. But I don't have that on the left. What I'm missing is I'm missing a plus 1. But I can add 1 to the left and add 1 to the right, and everything will end up really groovy. That'll be a 16. Now I can take the square root of both sides, remembering my plus minus case. So let's do it. And then I would solve it as I did those others. X plus 1 is either equal to the square root of 16, or x plus 1 equals negative square root of 16. Let's solve it. X plus 1 equals 4, In this case, x is 3, dunk, 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 or x plus 1 equals negative 4. Subtract 1 from both sides, x equals negative 5. Voila! Another way to solve these problems. So this completing the square, remember, it's not just about solving the problems. What you're really looking for, if you're going to do some circle work, is you would actually stop right here, because it's this position right here that you're looking for if you're going to work with circles and hyperbolas. So normally we wouldn't carry on if we were doing completing the square and we were working with circles. But in this case, they're wanting you to see, hey, here's another way to solve these problems. And you're like, well, yeah, like I needed another. Okay, let's say you're given this problem and you're told to complete this particular problem, solve it by using the method of completing the square. The first thing you'll do is scoot that 2 over. So you're going to say x squared minus 8x. Leave yourself some room and say that it equals negative 2 when it's on the other side. I want to make it look like a perfect square, so I'm going to do this. And then I'll say equals. If it was a perfect square, I need to figure out which one of these it would look like. Well, it would look like this one, except for it's a minus, and that's okay. I can handle that. I want it to look like x minus 4. That's how I'd get that minus 8. But I don't have that. I'm left with a blank here, so I need to add in what I would need. And negative 4 times negative 4 is a plus 16. That's what I would need on this left-hand side if it was to equal this x minus 4 quantity squared. So I will need to add 16 over here, which gives me a 14. And now I'm going to take the square root of both sides, remembering my plus minus case. Square root of both sides. Remembering my plus minus case. And then I have x minus 4 equals plus minus square root of 14. Square root of 14 doesn't really simplify, so there's no perfect numbers in it. I'll add 4 to both sides, and I'm done. And that, once you get the hang of it, is actually easier than using the quadratic formula, because you would have had to have used the quadratic formula on this one, because it won't factor beautifully, as you can tell by the answers there. All right, let's say we're given this one. We're told to solve this one by completing the square. Not what I would want to do. I'd probably use the quadratic formula if you just told me I had to solve it by any method. But that's not what they told us, so what I need to do is I need to move the 2 over. Now normally I'm looking for something squared and I just take half of that. Well, you know what? That's not a beautiful number, but I can still take a half of 5 and I write this down. I know it's ugly. So what I usually do to find this missing number here is I just square this guy. So that would be 25 over 4 that I've got to add to both sides. So I can tell you that when this number is odd, ugh, I don't like that. It's a mess. All right, so I can still do it though. You can too. So this minus 2 is like minus 8 over 4. So when I add those two fractions, I believe I get 17 over 4. Lovely number. I'm going to take the square root of both sides, remembering my plus minus case. Let's see, we'll use this red here. Remembering my plus minus case. Then I see that I have x plus 5/2 equals plus minus square root of 17 over 4. It's really nice. The square root of 4 is 2, so I can write that as plus minus square root of 17 over 2. That becomes nice. I'm going to subtract 5/2 from both sides, and this is what I get. And I probably still would have used the quadratic formula, but not if I'm trying to deal with circles and this is my end game. I understand that. All right, I'm going to do one more for you. you're told to find, let's say, the x-intercepts. Well, it's exactly what we've been finding, so it's not really any different. I'm not doing anything new, but I do need to do one more completing the square problem for you. So let's go back to doing one where I have an even number here. Makes me happy. The first thing you do is move your constant over, so that's a -7. Then I say, well, okay, what can this left-hand side be? And I take the half of that 6, which would be a 3. And there's what I'd like for it to be, but it's not that. So what I'm going to need to do is say, well, I'd like for there to be a +9 there. And there can be a +9 there if I add 1 to the other side. And then I can just say that this equals a 2. And then I'll take the square root of both sides, remembering my plus minus case. And I'll get x plus 3 equals plus minus square root of 2. Subtract 3 from both sides, and x equals -3 plus minus square root of 2. And that one is finished. All right, if you need any help with these, be sure and send me an email. These are sometimes difficult because you know there's an easier way to solve them, and that's what you end up wanting to do. But we need to learn to complete the square so that we can do circles and ellipses and hyperbolas later on. All right, have a good day.